So for sequences and series, we really need to dust off our understanding of limits and make sure we're fresh. And one rule that I would like to spend a couple minutes on in this video is L'Hopital's rule. And L'Hopital's rule, you recall, deals with things in indeterminate form. Indeterminate form. And from the English language, the word that indeterminate means that you can't determine it. Well, that's the same thing in math. You can't determine the limit through, traditional techniques or the tricks that we've learned that you may have learned in Chapter 2 in Calc 1. So we're going to learn a new technique, but we need to get it in a certain form. And indeterminate forms, there's many of them. The ones that we can use L'Hopital's rule for, you recall, is 0 over 0 and infinity over infinity. And if you have something in an indeterminate form, then you can use L'Hopital's directly. But there's other indeterminate forms that you need to be able to get into L'Hopital's form in order, into the indeterminate to be able to use L'Hopital's rule. And those other indeterminate forms are 1 to infinity, right? 0 to 0, or infinity to 0. Okay, so let's go through an example. I think that's the best. Hold on here. Let me pause for a minute. Find a good one. Okay, let's start with a simple one. So you're asked to take the limit as x approaches 2 of this rational function. So, like any limit, the first thing you always want to try is substitution, right? That's your first line of attack. So your first thing you try, substitution, and see what you get. If you get an answer, then your limit's solved. If you don't, you've got more work to do. So, substituting 2 in, you get 2 squared, right? Minus 2 times 2 over 8 minus 6 times 2 plus 2 squared. Well, you quickly determine that this limit doesn't converge to a constant. It's actually 0 over 0, which happens to be an indeterminate form that you can use L'Hopital's rule. So, how do I use L'Hopital's rule? Well, so substitution didn't work, you ended up here. Then the next step is to use L'Hopital's rule. So we're going to take the derivative. We're going to call this f of x, and we'll call this g of x. All right. So you're going to take the derivatives of f of x and g of x. Then you can divide them and take the new limit. So let's do that. Let's take the derivative. So f prime is equal to 2x minus 2, and g prime is equal to 2x minus 6. So now I'm going to take the ratio of the derivatives. Right, so you're going to divide and take the limit. So now the limit becomes, right, in general, this is what happens. Okay, so in this problem, we take the limit as x approaches 2 of the derivatives. A lot of kids confuse L'Hopital's rule with the quotient rule. It's not the quotient rule. Right, it's very different. You're only using this on indeterminate forms of 0 divided by 0 or infinity divided by infinity. So this converges to minus 1. All right? So that's your answer. That's the answer to the limit. The limit is minus 1. Let's do one more. This is a little bit longer. I'm going to pause here for a minute. Okay, so here's another example. we've got the limit as x approaches 0 of x cosecant x. Now this is in the form of 0 times infinity, and that's not a form that we can use L'Hopital's rule for. So we can do an algebra trick, and we're going to rewrite, right, and substitution of trig functions and trig identities. Cosecant x is 1 over sine x. Now, when I try and take the limit of this, I get 0 over 0, which is an indeterminate form that I can use L'Hopital's rule. So we're going to use L'Hopital's. And in this case, f of x is equal to x, right? G of x is equal to sine x. Taking the derivatives. And putting them back into the limit, right? I get 1 over cosine of x, which is 1 over 1, and I evaluate that, so the limit is 1. Okay, so here's another example of something that you needed to do a little bit of massaging to get it into the form that you can use L'Hopital's rule. But remember, it's got to be in, either 0 over 0 or infinity over infinity. I'm going to send another video of the related indeterminate forms of 1 to infinity, 0 to 0, infinity to 0.